Welcome to Module 4, Chapter 11, Sequences and Series. Which is better, $300 per day for 19 days, or getting a penny on the first day, 2 pennies on the second day, 4 pennies on the third day, 8 pennies on the next day? So we're doubling in pennies each day for 19 days. How about for 25 days? So both of these are examples of series, and series are when you add up the terms in a sequence. So a sequence is separated by commas, and a series is separated by pluses. So instead of me adding, though, $300 plus $300 plus $300, I know that I have 19 days. So if I chose that option, by the end of 19 days, I would have $5,700. That's a lot. And most of my students would take that because after a couple days, they could just quit the whole thing and they'd have $900 after 3 days. So I get that. But let's say we have to commit to the 19 days. And then we want to double our pennies. So a penny is 0.01. And I want to double that on the first day and the second day, and et cetera, et cetera. And what you'll learn in this chapter is that when you repeatedly multiply, it turns into exponential. So the 19th day will actually be like that actual 19th day. We will see a formula that it's n minus 1 times the first term there. So on that 19th day, just that one day alone, you will have $2,621. Now that's not the sum, that's just one day. That's kind of cool to think about, that those pennies have built up in such a way just after 19 short days. You'll also learn certain formulas that give you the total sum. And since this is geometric, which is the exponential piece, that formula is specific for doubling. It ends up being 2 to the 19th power, and then you just take away 1 penny. So this would be the sum after 19 days. Now, if you chose 300, that you'd rather have that, in this case, you're actually right, because I would have $5,242.87 with the pennies, and I'd have $5,700 with the 300. But you can see what I'm getting at. I mean, the next day and then the next day, choosing the penny option and choosing doubling is very powerful. So let's just see what it would be. The total would be if I went 25 days. So 25 days is this formula of 2 to the n minus 1, and I would have this many pennies. And that many pennies would be $335,000 as opposed to the 5,000. So $335,544.31. That's just crazy. Like, nobody does that. Versus, $300 times a whopping, 25 days, which is still a lot of money. Okay, but that's only $7,000, $7,500. So you can see the power of doubling, or the power of exponential. And you learned exponential functions earlier in this course, but a geometric sequence and a geometric series are exponential. Arithmetic sequences and arithmetic series, which you have done in another course also, those are linear. So repeated addition turns into a linear model, and repeated multiplication turns into an exponential model, which is kind of cool. Let's look at our Alex book, or our resource here. We will start with sequences and series and go into that arithmetic and then the geometric, and then comparing. In another course, I believe you would do mathematical induction and the binomial theorem, but I think for this course, we're just going to stay in the arithmetic geometric, and you're going to compare. But one of the most powerful formulas that you will learn is in this section for geometric, and it is the infinite model. So you can do something infinitely and still get a sum, which is just wild. You'll learn a lot of formulas. You'll learn a lot of terms. Common ratio is what you're multiplying by from term to term. And eventually there will be some sum formulas. So you have a geometric formula, which is right in here. You can see A1 times R, which was doubling in our case, raised to the n minus 1. And you'll also get formulas for sums. The sum is called a series. So right in here, finite series, you do that first, and then you will do infinite series, which is what I am interested in because, again, we do that in AP Calculus. Infinite geometric series. So this little infinity right there, just wild. The formula, let's see if we can find it right here. This I make my students memorize. It's the first term divided by 1 minus the common ratio, and you will get a total sum. So I do explain it in terms of filling up a vat of water. Like if I had, first I'm going to add a 1/2, and you could play around your calculator this way. So you could say, first I have a 1/2 gallon of water, and then I'm going to add that to a 1/4 gallon of water, and then I'm going to add that to an 1/8 of a gallon of water, and then I'm going to add that to a 1 divided by 16, whatever fraction that is. So I'm cutting the bottom, I'm doubling the number on the bottom. So 1/2, 1/4, 1/8, 1/16, 1/32. If you've ever played that game, 2024, you are familiar with 32s and 64s, etc. Now, if I only just add those few up, I get a decimal very close to 1. But if I keep going, what's amazing about this is that I will get a number that does not exceed 1. So what I'm saying is if I pour in a 1/2 gallon and a 1/4 a gallon of water, I only need a 1-gallon jug, and I'm continuously multiplying by 0.5. Okay, so this formula will give me the sum. Even if I kept doing this forever, I would not have anything more than the sum of 1, which is just crazy. Just crazy. Kind of like looking at the fractions more than I did that on the calculator. So it's very similar to what we just did with doubling, but we're doubling on the bottom. The catch with a geometric infinite series, this doesn't work for all of them. Like clearly the doubling was not going to happen where I get a sum. Like I can't keep doing this forever, right? So, but if your common ratio is less than 1, or actually greater than -1, so it's the absolute value. So if it's a fraction between -1 and 1, you will be able to use the following formula. Infinite geometric sum is the first term divided by 1 minus the common ratio. What I'm doing from term to term, yes, I know the bottom is doubling, but really I'm multiplying by 1/2 to go from term to term, and that is equal to 1. So have some fun with these patterns. If you're a pattern person, you're really going to enjoy the sequences and series because you're either repeatedly adding, and that would be arithmetic, or you're repeatedly multiplying, and that would be geometric. They might throw in a couple other sequences in there just for some interest, like Fibonacci sequence and the words recursive. But so pay attention to the language, and good luck with your Alex.